Alright, good day students. How are you doing? This is me again, Sir Navarro, and welcome to our YouTube tutorial video. In this video, we're going to discuss about direct variations and a few applications, probably two problems. Alright, let's proceed. So, direct variation. What is a direct variation? So, yeah, direct variation is whenever a string produces numbers, pair of numbers in which their ratio is the same or are the same, which is constant. So commonly it is written in these three phrases. It can be y varies directly as x, y is directly proportional to x, or y is proportional to x. And these statements are just related or translated to just one equation, which is y equal to kx. So next, k there is what we call the constant of variation. Now, a direct variation, commonly we have this uh, description of it. So when one quantity increases, the other also increases, and it goes similarly with a decrease when an x decreases, also y decreases. Right? Let's proceed to the examples. So here we have four steps in solving given set of problems. First is you write mathematical statement, solve for k, and then write the equation, solve for the missing variable. But yeah, we're not going to apply everything at all, everything on that, except some problem solving now. So here we write the we write the mathematical statement. Let me just make erase. No. First is you understand first the problem. Y varies directly as x and y is 24 when x is 6. Find the variation constant and the equation of the variation. So first is you have to translate the mathematical statement or the variation statement that is given in the problem. So in this case, it is translated to y equal to kx, right? Because y is directly related to x or varies directly as x. So y equal to kx. Now we do step 2. Substitute the values. No, first this one, first pair. Y is 24 and x is 6. Then we divide both sides to solve for k. Yes, by 6 here. Okay, so k is 4. So if k is 4 and then you have to do step 3, then you have to replace the k here. So then your equation will be y is equal to 4x. Here? Alright. Next item. This is a table of value. If given the table of values, you can actually choose which pair you want to use. But yeah, it's up to you. Depends on how you what is more convenient, as long as you see that the table represents a direct variation. I've already discussed that. When can we say that a table value describes a direct variation? So you can watch that video in the other in same channel. So now we have the translation. D is equal to kt. So we need to find the constant of variation and the equation. So there, we choose 220 and then just simply substitute it here. Okay, so our d is 20 and t is 2. So therefore, our k is, divide both sides by 2, our k is 10. Clear? We're not done yet. You still have to find the equation. So the equation will be, just replace the k with 10. So therefore, the equation will be t is equal to 10t. Alright? Let's proceed. Maybe this one is better than here. It's better than here. There. So if y varies directly as x and x is 35 when y is 7, what is the value of y when x is 25? So there, we can do two methods on this one. Right? So since x varies directly as y, then the equation can be x equal to ky. So again, if the first letter is different, you have to follow that the first letter stated should be written on the left side of the equation, and the other letter should be together with the constant of variation k. But yeah, you can interchange them, yes, but usually we write whatever the first letter stated, it should be written, no? We usually write it on the left side. Yeah, but still it's equal if you write it on the right side. As long as the constant and the second variable stated is together, they are together. Right now, we replace, for the step 2, replace the values, no, which is our x is 35 and 7 is y. So there, we divide both sides by 7. And k is what? K is 5. Right now, you need to find the equation. Therefore, what you need to do? To find the equation, you replace lang the value. Diba? Ba? So replace lang the value. So there, our equation is x equal to 5y. And then, this is our equation. Then we can solve for the y now. So there, we replace lang x, which is 25, then equal to 5y, and divide both sides by 5. Then we can say that y is also equal to 5. Alright? So I've said earlier that we have two methods on this one. So you can just do it like this. You can use this format, right? The ratio. Okay. So where did you get this? But when you have given two set of data, their product, or their ratio are the same. So you can have it like this. Alright, so your first pair of data is x equal to 35 and y is equal to 7. Second pair is missing ang y and x is 25. So you now make a table. Sometimes the given is in table format, but sometimes it's in this problem format. Alright, so now we replace the values using here. Just substitute first. Let x sub 1 35 and y sub 1 7, x sub 2 25. So there we can say that this is the result. No? 35 over 7 equal to 25 over y sub 2. Just divide this will be 5, and then you can just simply interchange y sub 2 and 5. So there, your y sub 2 is equal to 5. Check. Same earlier, right? Let's proceed to number 4. Oh yeah. Here, we have this what we call direct square variation. So basically, I'm introducing to you basic foundations of, because there are a lot of direct variation. No? It could be square, cube, 4, blah blah blah. No, it depends on the situation or the problem that is given. So I'm just giving you an example for direct variation. So what is a direct variation? Let x and y denote two quantities. Y varies directly as the square of x if there is what? A non-zero case such that y is equal to kx squared. So same gapon, the constant of variation is k. It's just this time our x is not x, simply x anymore. It's x squared. Alright? It's like this na. Now let's proceed. For examples, number 4, if y varies directly as the square of x and y is 432 and x is 12, find y when x is 20. So there you have to write a table of values. It's optional anyway, it's optional. So the missing is y, and yeah, you write the variation statement. So y is equal to kx squared, since this is the statement. Okay, so now you replace the first set of data to get the k. So to get the k, your y is 432 and your x is 12. Okay, before you divide this one here, you need to square it first. So you divide it by the square of 12. No? So there, you can say that 432 is divided by 44. So just the square of 12 is 144, and then cancel. You can say that k is equal to 3. Now if k is equal to 3, we can now make the equation. So you just replace the k here with value of k, which is 3. So there, our equation is y is equal to 3x squared. If our equation is y equal to 3x squared, then we can now find the y. If y is equal to 3x squared and x is 20, so we can replace 20. 20 squared is 400, and times 3, that's 1,200. Alright, questions so far? Alright, let's have the next example. If if y varies directly as the square of x and y is equal to 48 when x is equal to 4, find x when y is 12. So the same statement, but this time it's asking for the x. Earlier it's asking for the y. So there, we now write the equation, variation statement, translation of the variation statement, then replace the values to find k. So 48 ang y, x is 4. So 4 square is 16. So we divide both sides by 16. So k is 3. So now our equation will be y is equal to 3x squared. Similar earlier, but the given is different na. 12 ang y, x is missing. So here, commonly, they only divide 12 by 3. They only divide 12 by 3. But we are not looking for x squared. We are looking for x. So, meaning, we need to divide it first. I mean, not divide, sorry. It's square root. Now, extract the square root on both sides. There, square root of x squared equal to plus or minus square root of 4. Which negative 2 is actually okay, usually. But especially when we deal with problems later, we usually use the 2, positive 2. Okay, so therefore x is equal to 2. In this case, negative 2 is possible also. Okay, let's proceed. For the problem, the distance that a car can travel varies directly with the number of liters of gasoline in the tank. If a car can go 120 kilometers on 15 liters of gas, how far can it go on 9 liters? So I have here present 5 steps, on solving problems involving direct variation, or even inverse variation. So first, similar earlier, write the mathematical translation of the variation statement. Make a table of values of the given set of data. Substitute the first set of data to find k. You write the equation, solve for what is being asked. So now let's go with the first step. Let's translate this statement. Distance d. Let's represent lang d, distance as d, and then the time of the gasoline in liters, L. So therefore, d is equal to KL since travels varies directly as the number of gasoline, liters of gasoline in the tank. Now, what is the second step? Second step is make a table of values. So we make a table of values. Let's move this one right here. So L, D, and then first pair is 120 and 15. So 120 is the distance and 15 is the liters. So there. And then the second part is how far it's asking for the distance. This one is question mark, and this one is 9. So let's go for step 3. Substitute the first set of data to find k. There, we replace lang first set of data. Then we solve for k. K is equal to 8. K is equal to 8, then our equation will be d is equal to 8L. D is equal to 8L, we can now solve for the distance. Just replace the value. So liters is 9, so 8 times 9 is 72 kilometers if it has 9 liters of gas in the tank. So I have here last one example. Actually this is Seclor. The proper dosage for 9 kilogram child is 124 milligrams. How heavy should a child be in order to be given dosage of 165.33 milligrams or 496/3 milligrams? So mao gyapon, we're going to use the same steps, So just follow the dosage and the weight. Then table of values, weight is 9, so 124 milligrams, and then asking for the weight. This one is the milligrams. Substitute, find k. So k is 124/9. So if k is 124/9, therefore our equation is d is equal to 124/9W. So we now solve for what is being asked. This is our equation. Replace the d with, or the dosage with, this one, 496/3. And then we divide both sides by 124/9, which is equal to 12. Meaning to say that the child, this is W, W. The weight of the child must be 12 kilograms. in order to be given the dosage of 165.33 milligrams.